In this video, we'll be solving this geometry math problem relating to the Pythagorean theorem and side length of a triangle. So here we have this diagram, and what they want us to do is find the length BC. So right here is B, and here's C. So we've got that lower line there on this rectangle, and we need to find that length, and they tell us some of the lengths already. We know 20, 35, and 5 there. We know we've got right angles on this rectangle, obviously, and we've got the triangle AED on top. So to solve this problem, we're going to need to leverage the Pythagorean theorem. Since we know that this is a right angle here, because we got a rectangle down there, and this meets at right angles. So we do have a right triangle here. We've got AED is a right triangle. So we can apply the Pythagorean theorem here because we know two of the lengths of the triangle already. It's just a straightforward application. We know that A is going to be the AE side length. So if the formula, again, for the Pythagorean theorem is A squared plus B squared equals C squared, where the C squared is the hypotenuse, the longest side of the triangle, which in this case is AD, or 35. So we've got A squared. Our A is side AE. And so AE has length 20. We can fill that in. So what we're going to, in fact, though, we've got the 5 over here. And we've got the 5 over here on EB as well. We should write this in so we know what we're doing here. So total AB has side length 20. The diagram is a little bit ambiguous here. AB as a whole has a side length 20. EB has 5, so we have to do 20 minus 5 to get 15 for the A. So we've got 15 squared, in fact, plus B squared is unknown. We'll leave that as B, equals hypotenuse squared, so 35 squared. So this is going to be a pretty unfortunate equation to solve. These are very large values here, the 15 and 35. We wouldn't want to deal with this. So what we do instead is we would scale this entire equation down by 5. We're essentially dividing it by 5. So we would get 3 squared plus the B squared, we don't know what it is, so it's not scaling anything. So then 35 squared scaled down would be 7 squared, since 7 times 5 is 35. So now this is a much easier equation to solve. We have 9 plus B squared equals 49. All we have to do there is isolate the B squared. We essentially have B squared equals 49 minus 9, which means B equals square root of 40, since 49 minus 9 is 40. So this is our value for B right here. Not the squared value, B itself is equal to square root of 40. And so what does B represent here in this diagram? Well, the B is the medium leg of the triangle, which in this case is side ED. So it's this long line here. And so since we have a rectangle in the lower portion of this diagram, rectangle DEBC, we also know that the desired side length BC is also equal to ED. We got parallel, the same length here, the right angles. We know BC must also be equal to square root of 40. And so there it is. We've solved the problem, and we've gotten to an answer of square root of 40 for the length BC. So essentially how we solved that problem was we applied the simple Pythagorean theorem here for lengths A, B, and C. We didn't know B, so we had to change the equation slightly. We had to scale down the values to make it easier to solve. And then we arrived at the conclusion for ED, which we used to find BC.